From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show.
If you work on an Android app, and if you're listening to this podcast, I'm going to presume you do, you'll know that when your user reports a problem or a crash, it's the absolute worst feeling. To make matters worse, they might one-star your app, go on Twitter and complain about the app, and if they're feeling particularly merciless, probably go on Reddit or something and post it there. But you know what? They have absolutely every reason to. If you treat your customers basically as an offsite QA team, it's rude to them and it's just bad for business. As developers, we don't want to rely on customers to report errors. Instead, we want to catch this much early on. Ideally, you just have automated tests and these tell you when there's a problem. But, as we've talked about on the show multiple times, that's not always as easy as we want it to be. Because writing tests can be hard. That's why Sentry, our sponsor for today's show, tells you about errors in your code before your customers have a chance to encounter them. Not only do they tell you about the errors, they also give you helpful details that help you fix these errors. For example, how many users were impacted by this bug, the complete stack trace if it's a crash, the commit ID when this error was released, the engineer who wrote this line of code that was busted, that and a whole lot more. If your code is broken, let's fix it together. That's Sentry's tagline. Love it. You can check them out at sentry.io/for/Android. Sentry is a pretty common word. It's actually a pretty cool name for the service if you know the English meaning of the word. But I want to make sure you get that domain name right. It's sentry.io. Once again, sentry.io/for, as in FOR/Android. Check them out today and fix your errors before your users encounter them. Thanks for sponsoring today's show, Sentry. All right, I am super happy in this episode to introduce Donn. Now, you folks might be thinking, wait a minute, you've been talking to Donn all these years. Well, in this episode, it's a little different because I'm actually talking to another Donn, and I'm really excited because it makes me feel like nice and warm and fuzzy that Donn is still here, but it's a different Donn. In the early days of Fragmented, I always complained and lamented that it wasn't that easy to build a really low latency Android application. It was just not there for some reason. I even talked about like this app early on that I tried to build that I was unable to because the latency was not just there. But what we've noticed is with Android Q and a lot of the announcements that are coming in, Google has really upped the game, and it is no longer the case where like you cannot build these apps in Android. But it's been some time. So what Donn and I wanted to do was actually reach out to one of the folks at Google who is highly recognized in this industry. And he's also written a wonderful open source app. So without further ado, let me introduce in this show, Donn Turner. Welcome to the show, Donn.
Hello. Very pleased to be here. Thank you.
Yeah, our pleasure. Now, I have to kick this episode right off and tell you that I did initially fanboy a little once I knew that you were going to come to the show and we were going to be able to talk to you. And this is actually for reasons different from what most people know you from. This is basically, so I follow this music production company. They build a lot of software for music editing and such, and they're called Isotope. And I noticed they had a blog post, and I'll make sure to post a link in the show notes for this. It's called The Future of Audio Production on Android. That's a blog post that they wrote. And they did actually make mention of you in this. blog post. So yeah, this is an additional like FYI. Thanks for coming on the show.
No problem at all. No, I don't think I've ever had a fanboy before, so this is a first for me. But no, I read the blog post from Isotope. I mean, Isotope are a fantastic company. They make well, for a long time they've made brilliant audio processing plugins, and more recently they launched a product called Spire Studio. And yeah, they've got a fantastic story about what they did on Android. Essentially, their revenue went up by about 40% after they launched their app on Android, which is really, really encouraging. I mean, it's fantastic to see Android users willing to spend a lot of cash on high-end recording hardware. So it's kind of sort of flies in the face of the popular stereotype that Android users don't spend a lot of money on hardware. Evidently, that's not the case. So yeah, really encouraging message from Isotope. So all good.
I know. I mean, you just had to ask me, like, yeah, Android users who don't spend enough on high-end audio hardware. Like, I've lost many a salary to high-end audio hardware. So I don't know where that message has been coming from.
Right. Cool. It's good. It's really good.
A quick question on that. So I do know like what Isotope, and this is like definitely one of those things. And this isn't just like a myth necessarily, because I know in the early days when I started to build Android applications, and I'm talking like, some time back now, like probably 6 to 7 years. One of the applications that I've always wanted to be able to build is, I'm not sure if you've noticed these applications. So it's almost like a looper application. So what you can do is you record a certain music snippet, and then you can it keeps looping in on a standard beat. So then you can keep layering on multiple sort of like audio snippets, and then like you can build harmonies, or you can like add drum beats. You can add like different things. This is like one of those things that I've tried to build on my own, but I've basically not been able to build. So I do know this is like a real problem. This is not something that, I was just imagining. What changed in that time? Or was this ever like truly a problem, or was I just like doing things wrong? Can you maybe like quickly give us like a background as to why is this even a problem, or why was it perpetrated in the Android development world as being a problem, if that makes sense?
So let's look at the fundamentals of what you're trying to do. So you're attempting to take the audio data from the microphone and store it in memory, and then essentially just play it on a loop whilst recording a new stream, which gets played over the top, and essentially you're layering up loops of recorded data. So I think one of the problems in the past has been to do with input latency. So when you actually hit that record button, it might take a few hundred milliseconds for a recording to start. I know there's been issues with resampling in the past, which have caused extra latency in the input signal path. It's also been difficult as well to get the APIs doing exactly what you want them to do. So, I mean, there has been you can use the Java audio record APIs. That's been around for quite a long time. I think the simple answer is it has always been possible to do this, but there's been a lot of hoops that you would have to jump through in order to get the performance level that would be required for this type of app, and also it would only run on a very small subset of devices because of latency issues.
I see.
Nowadays, because the audio ecosystem, or rather the ecosystem of devices which have much lower latency, is much larger, and the APIs are better. It's much easier to implement an app like an audio looper. And I'm sure we'll talk about this in a bit, but one of the reasons behind this audio library Oboe, of which I'm one of the authors, was to make it a lot easier for developers to build these types of apps. So instead of having to write, say, 100 lines of low-level C code in order to create a recording stream, you can now do it in, say, 5 lines of code, and it's much easier for you to just say, hey, I want a block of 8 seconds of audio data from the microphone, and I want to loop that audio once it's in memory. So yeah, I think there's quite a few factors which have made it a lot easier and I suppose more viable to create that kind of app and have a positive user experience and potentially make good money off it.
So this is like a lot of juicy stuff that you just mentioned. So I'm going to like probably like peel some of these layers back. So I'm pretty familiar in some terms with audio latency, but for the folks who aren't necessarily aware of what audio latency is, specifically how that problem manifests, could you like maybe give us like a quick rundown on what is the problem with that latency in like if you're trying to build like a music editing app or something?
Yeah, sure. Okay. So latency a is quite simply the time it takes from some kind of trigger signal to some kind of output. So a good example of this would be when you tap on your mobile phone screen and you want to create a sound, as in the sound that's produced either through the headphones or the speaker. Latency would be the time it takes from actually your finger physically touching the screen and that sound being reproduced by the phone's speakers or headphones, as in the manipulation of these the speaker cone in order to change the air pressure to create that sound. So there's a number of things in that signal processing pipeline. You have the touchscreen sensor. So there'll be typically between 20 and 30 milliseconds on a high-end device for that touch event to be registered and sent down into the Android subsystem. And then the event would be presented to your app, and it then would need to be processed. It's probably a few milliseconds there. And then we're into the audio latency side. So at this point, your app needs to generate this sound, whether it's pre-recorded or you might synthesize it if it's some kind of synthesizer app, send it into an audio stream, and then it's down to the Android framework to take your frames of audio data, send it through the whole software and hardware stack which is underneath that, and then have it presented at the speaker. So there's a lot of stuff which goes on, but ultimately what it means is if you've got a live performance type use case, so you're tapping on the screen and let's say it's a virtual keyboard, you need that sound to be played, I would say, within 50 milliseconds in order for it to feel responsive. Anything above sort of 50, maybe 60 milliseconds, it's going to feel like, okay, this doesn't feel like a real sort of musical instrument. It's not, you're having to, your brain can compensate for a little bit of latency. In fact, if you were, say, a professional church organist, you would be used to compensating for anywhere up to about two seconds of latency between tapping a note and hearing that sound produced by the pipes in the organ.
Wow, that's crazy. That's almost like a sort of like, that's almost like a talent, because 2 seconds doesn't seem like a lot, but that's crazy. 2 seconds of latency.
It is.
Yeah.
And it must be so strange to hear that sound. You've already moved on to the almost the next section of music by then. But if you're a professional musician who's trained in this, then that's what you do. For most people, what you want to do is your brain says, okay, I want to make this sound, and you want to hear it almost immediately. So that's why audio latency is very important. And I think in the past, it's been one of those things which sort of got lost in the mix of other priorities for Android, both on the Google side and on the OEM side, and that's why we saw, I'm talking sort of over 5 years ago, we did see some devices which had audio latency in the order of a few hundred milliseconds, but I'm very pleased to say that's very rare now. And a lot of flagship devices now are looking at 50 milliseconds or below. I mean, Samsung's flagships are now looking at about 20 milliseconds. The Pixel devices around about 20 milliseconds as well. So, there's a lot of progress being made on that side.
And again, I had two quick follow-up questions. One is like the church organ story. I'm like, that's like super interesting. And I imagine the idea there is because like for folks who have like seen churches, like it's a massive space and there's like a lot of feedback and echo, but also the fact that when you have church organs, they're wired so that when you like tap a keyboard sound, for the sound to actually like resonate and travel through the whole room, it actually, I imagine, takes about 2 seconds. And that's probably why. Right? Or am I misunderstanding some aspect of that?
So I'm not an expert on church organs, but I think the way that the sound is actuated is through a blowing wind down a pipe. So it has to actuate some. I could be completely making this up, but it must actuate some pump which pumps air into the pipe, almost like blowing into a flute, something like that. And that's the bit I think which takes the time, because it's got to go.
Causes the latency. I see.
Yeah, I'm guessing. I don't want to tell you something that's just made up, but I know it takes quite a while.
We can leave it to as a lesson for the listeners to do the homework and report on why we are wrong or right. The other follow-up question that I had was, so you really broke it down well when you talked about like why there is that gap or that latency from the point of like initiating like a feedback or a touch on the screen to when you hear it back. In that pipeline, in the past, what was the most problematic aspect of it? Was it purely just the hardware, or like the not being able to respond, or like the computation process in all of this combined, or what was like, if I had to visualize how like the amount of time being spent on each of those components or those parts, which is the part that would have taken the longest time?
So I would say in equal parts, it would be the Android framework itself. So there was a lot of. So another way of thinking about this is, what you want for most users is to have just completely glitch-free audio all the time. You just want, most users, they want to play a song, and they certainly don't want to hear any artifacts in that song. And what would happen would be a device would be tested and it would have some audio glitches. And in order to fix this, somewhere in the audio pipeline, you would just add in an extra buffer to say, okay, we'll just extend the amount of audio data that we read in before we send it out to the speaker. And this would happen at multiple stages throughout the audio pipeline. And what you'd end up with is enormous buffers inside the Android framework, but also at a hardware level as well. And this would solve the problem. Solve the problem for most of the users most of the time, except for these real-time use cases where people wanted to do something where they tap on the screen, or maybe they plug in a keyboard, or something which is responsive. So yeah, there's two areas. The Android framework itself was using a lot of large buffers and was sometimes resampling when it didn't need to, which again would introduce buffers into the audio pipeline. And also OEM devices would do things like acoustic treatment of the output signal. For example, so you're talking about very small devices with fairly small speakers. Sometimes if you do some DSP on the output signal, you can do like improving the bass and noise cancellation, these kind of things on the output path, which make it sound better, but also introduce latency. And sometimes this latency was excessive. So I would say in equal parts on the OEM side, the low level hardware drivers and the DSP, which is done on the audio chips, but also in the Android framework, would have this kind of extra latency. The other thing I'd say is previously it was much more difficult to bypass all of these extra buffers, which are sometimes quite useful. You might want to have like echo cancellation and noise cancellation on your output stream if you're not bothered about latency. The problem is you don't want it all the time, and I think in the past it has been quite difficult to avoid that extra latency, whereas now it's getting a lot easier. We provide much better guidance, and then we have this library which does all of the kind of heavy lifting and picks the optimal low latency path for you, rather than you having to know the special kind of incantation of sample rates and formats which are going to get you this kind of golden low latency path. Oh, hey, Dom.
Hey, how you doing? Good. I've just been kind of silent here, hanging out, listening. So I'm going to hop right in here. I've heard a lot of the talk about the audio latency, etc. And I kind of wanted to shift gears a little bit and talk about, and I don't know how to pronounce this, but it's a project that it seems like that Google has created. And it's OBOE. And from what I can tell from the GitHub page, is that it's a C++ library that makes it easy to build audio apps on Android that are high performance, which is probably something anyone who's an audio programmer is excited to hear. I wonder if you could talk a little bit about what that project is, maybe how to pronounce it, and maybe why folks might want to use it.
It's funny about the pronunciation. So the correct pronunciation is oboe, as in after the musical instrument. Oboe, it's like a long pipe, and oboe basically creates pipes, right, or pipes of audio data, essentially. That's where it came from. But my French colleagues in the office call it oboe, with an accent on the e, which I think it sounds a lot more eloquent, but technically it's just oboe. But yeah, so I'm one of the authors of that library. I have to say, not the only author, and the original idea came from one of my colleagues in the engineering team, Phil Burke, who's done a fantastic amount of work on this. So the original idea behind oboe was to create a library which was easier to use than the current APIs. Now, not that the current APIs are difficult to use, but they are very low level. So they offer you a lot of control, but they also require kind of a reasonable level of understanding and quite a lot of boilerplate code. So that...
Yeah, if you can give us an example, like for example, what would be something that you think is like low level versus like something that's easier to do that oboe gives us?
Sure. Okay. So in the beginning, the only way that you could get really low latency audio was to use an API called OpenSLES, which is Open Sound Library for Embedded Systems, and it's a C API. It's been around for a very long time. And in order to get a playback stream, you would have to write between 50 and 100 lines of code. And it would be things like every time you wanted to access a certain part of the audio subsystem, you would have to write an interface to that particular part. So you'd have to have an interface which set up your sample rate for that stream, an interface for the channel count, an interface for the format. And there was a lot of kind of boilerplate code in order to set up this audio stream, which should be a fairly simple thing to do. You just say, "Hey, I want to play a sound. You pick the best parameters for me, and I'll just supply data in that format." So, so oboe helps with that. But what happened with Android API 26 Oreo is we launched a new API called A-Audio. Which had a lot of new features. Again, was a C API, but was kind of a lot nicer to use and takes advantage of features of newer devices which allow you to get lower latency. For example, memory mapped buffers. So your application can write into a section of memory which is then immediately read by the audio hardware. So it cuts out virtually all of the buffers which used to be there, which were adding all this extra latency, which is great. We have the best possible performance on devices which support it. However, to a developer, this represents quite a big problem, because if you want the best performance across all devices, it means you've got to write code against two APIs. So Oboe was invented to solve this problem. So you just code against Oboe, and Oboe says, okay, well, if a device has audio on it, then the newest and greatest API, then it will use that. Otherwise, it'll fall back to using OpenSLES and handle all of this like boilerplate code for you. So yeah, essentially you just write against a single API, gives you the best performance across the widest range of devices, down to, I think, API 16, which is like virtually 100% coverage.
It's almost like, kind of reminds me of like AppCompat and ExoPlayer and stuff like that. Where
Exactly right. Yeah, and another good comparison is Angle for OpenGL. I'm not sure if you're familiar with it, but it uses Vulkan on devices that support it, and then falls back to OpenGL on devices that don't. So yeah, it's just about making it easy for developers really to write these types of apps.
So if I wanted to, let's say I'm listening to this right now, and I would like to start digging into it and maybe start building an app with words, like what are kind of the steps that I should follow to get started? And is there like an example projects I can play with, or kind of how do I get my feet wet with this project? Absolutely,
right. So I recorded a video series quite recently called Getting Started with Oboe, which is on YouTube. If you just if you just search for Oboe GitHub, I think it's the first result. And on there's a whole load of videos to help you get started. There's also sample code. And, the way I've split up the sample code is kind of based on use case. So if you're building a synthesizer, in fact, to get started, there's just your Hello Oboe project. That just kind of goes over the basics. But then we go on to more kind of complicated use cases. So there's a sample called Megadrone, which uses, I think it's like 100 or 150 oscillators to create kind of this weird and wonderful sound. And the idea behind that is, if you're creating an app which has quite high computational load or computational bandwidth requirements, then it shows you how to like optimize your app using optimization flags, and goes through how to profile your app so you know that you're always going to be meeting your audio callback deadlines. And there's another app called Rhythm Game, which is much more based, it's sort of kind of like Guitar Hero, where you have to tap on the screen in time to certain rhythmic events. So depending on what you're trying to do, there's probably a sample which sort of hopefully goes some way to illustrating the sort of the key concepts behind that use case. So yeah, head to GitHub. Everything should be there. If it's not there, just file an issue, and I'll try and address it.
That makes sense. So diving in a little into Oboe, so this is a C++
That's
library?
Right. Yep, it's C++. You're probably thinking, well, why is it C++ and not Java or Kotlin? And the answer is, C++ is still best for performance. C++ by default doesn't have a garbage collector, whereas Java does. So the main thing about these kind of real-time performance use cases is they must always supply audio data at certain times. So they must always meet their audio callback deadlines. And that means not having anything which is going to block your audio rendering thread. And unfortunately, in Java, Java's wonderful. I grew up on Java, but it has the garbage collector, and there's nothing which stops the garbage collector running at any time that will block, and that may cause
Right.
cause an underrun, which, it's not catastrophic, but no one likes to hear audio glitches. So that's why it's in C++.
That makes sense.
The other reason as well is, there's a lot of fantastic audio apps out there, and many of them are using code which is written in C++. So, and if the vast majority of your audio rendering code is in C++, it doesn't really make sense to have you kind of calling out back to Java and some other library. It's just much easier to interface with the same language.
No, you mentioned some libraries here too. So that's kind of in the same vein. If I wanted to take the the digital signal that's perhaps coming in Oboe, it might provide like some hooks that I can use to process that signal. Maybe I've come up with a new fancy way to do noise reduction or something like that. Is that something I can kind of hook into inside of Oboe?
Yeah, sure. Yeah. I mean, there's a couple of ways you can do it. If you're recording audio data, you can either just read directly from the recording stream. You can have your own thread, which is adding some kind of noise cancellation or whatever effect you want to add, or you can be called every time there's new data ready. So it will call you on a callback. In fact, if you look at, there's a sample called Live Effect, and in that, all that happens is the recorded data is immediately played through the speakers or headphones. And there's, I think I added the comment, which is add your own effect here. So it will present you with the input data. You can do whatever audio processing you want to do, and then it gets sent to the output. So, we were thinking sort of guitar pedal effects or vocal processing for karaoke apps, that kind of thing. So, if that is something you want to do, then check out the Live Effect sample.
Has this library or anything like it been used in any do you know if it's been used in like any video games or anything like that, or what are some like use cases that have been kind of interesting for the library that you've seen so far?
I mean, there's a really popular framework called Juice, which is now using Oboe. It's still in beta, so that you have to activate it with a flag. But yeah, Juice is very popular. I think it's used by some fairly large companies. I wouldn't want to quote off the top of my head in case I get it wrong, but it's certainly a very popular library or framework rather. C-Sound is another one which is pretty popular. Let's see. There's actually a list. I'm on the site now. Let me have a quick look. There's G-Stomper. Probably shouldn't be biased, but G-Stomper is a fantastic. I've
played with that before.
Yeah, it's a really like comprehensive audio workstation which runs on your phone. So they're actually using A-Audio and OpenSLES just so they get the like absolute best performance everywhere. N-Track.
Oh, I see. There's a whole list here on the site. Projects using
right.
Oboe or A-Audio.
Yeah.
I see that. Yeah.
So it seems pretty popular.
And you said Juice. Juice. That's not the same Juice. It's from
right.
like Google. That's a different one, like JUCE, right?
That's it. Yeah. It's a third-party library written by a company called Roly. They make like fantastic like silicon-based keyboards as well.
I just want to make sure it wasn't the same library that is produced by Google for development, which is GUICE.
Yeah.
So people might get, especially listeners, definitely might get confused. Okay, that's cool. There's a bunch of stuff that's inside of here for those projects using A-Audio. I've actually played with G-Stomper, not even knowing that, just recently, kind of playing around with some, making some audio. It's very cool that it's used it.
Cool.
That's pretty cool, yeah. And I also know, like, one of the companies that I use, I mentioned this early on, Isotope, they have, like, some of their stuff also that uses, like, Oboe now. And they actually have a blog post, too, and I'll make sure to add that in the show notes, where they explicitly point out that they worked with Donn and, like, the Oboe library. So I was, like, actually very surprised, because I use a lot of their tools. So, yeah, definitely being used a lot in the community now.
We like to think it's been battle tested. Obviously there's always outstanding issues, but it has been used by a lot of partners now, and we get a lot of good feedback of it. So it's definitely the recommended API to use if you're thinking about doing any kind of real-time app for audio. It's it's the place to be.
Makes sense. And just two quick follow-up items for folks. I know we mentioned DSP. I just realized like we probably use that term casually. So DSP in audio editing land is digital signal processing. You can like look into Wikipedia for like the full definition, but that's basically what Donn was mentioning when he said DSP.
Using acronyms.
And the other one's a fun one. If folks want to know more about oboe, the only reason I knew what oboe meant was there's this TV show called Mozart in the Jungle, and it's based around like the lead character playing this instrument called the oboe. So if you want to do even more further research before you start working on oboe, you can watch those TV shows.
And it's weird because the reason why I asked that question is I used to work with some folks that were ex-Google, and we had created an app for some company, and they called it Ubi, which is like OOBE, which means out-of-box experience. And so I saw this, I'm like, wait, is this like a alternate variation of that? So very interesting.
I think we need to make it more obvious what it is, as in just a picture of an oboe, and maybe, I don't know.
Or just or maybe like an emoji on the side after or something. So
picture would help.
Unfortunately, it's run completely by engineers, so we haven't had much design. I mean, it's open source, so if any budding designers out there want to help out with the oboe logo, we are accepting pull requests on that.
There you go. There's your opportunity.
Yeah, that's to be part of the oboe library. All right, so that. I loved some of the concepts that you talked about with oboe and like why it's used and how powerful the library it is. But also one of the main topics we wanted to talk to you about, Donn, is Android Q. I actually remember was it Android? I'm not sure if it was like Nougat or maybe Marshmallow. There already were some audio announcements being made saying that like they've improved a lot with like a media player and a lot of those things. I hear on Android Q there's like additionally some really cool stuff that's going in specifically with some of the audio capabilities. Can you maybe give us like a rundown of what to expect for Android Q and some of these improvements in the Android framework as they've happened?
No problem. So I mean, following on from talking about oboe and these real-time performance use cases, there's a new API called the native Midi API, which allows you to communicate with Midi devices. Now, I'm guessing some of your listeners might not know what Midi devices are. Well, Midi devices are controllers, essentially. So it could be a keyboard or drum pads or faders, which you would plug in to your computer or phone, and it sends data in order to control your audio software. So probably the most obvious example would be to plug in a keyboard and have your mobile phone make the sound of a piano. So now this has been possible since Android Marshmallow. It's been possible. There's been the Java Midi API, and before that you could do it by packaging your app with a USB Midi driver. But in Android Q, we introduced a new API for doing this natively using C++. Now, some people, I mean, this is some people are like, well, why bother with that? It seems like the functionality was already there. Well, the truth is, it's all about performance. Mm-hmm. So when you're writing an audio app, generally you're doing all of your processing inside this audio callback. If you then, inside your audio callback, need to jump out to Java, through JNI and grab some data through Midi and then come back into C++ land and update settings and things like that, then it can be a performance bottleneck. And this is what we heard from developers. And it's also, being honest, it's a bit of a faff. You have to, there's quite a lot of code you have to write in order to make this work. So with the native Midi API, it makes it super simple to just get all pending Midi data from your keyboard or drum pad or whatever other device you're connected to, do the processing immediately, and then render the audio out. So yeah, it's all about performance.
I like that. And so just to recap, the Android native MIDI API is what's being introduced with Android Q, and Android Java MIDI API is the one that was before, right?
That's right. The Java one was introduced in Marshmallow.
Oh, Marshmallow. Okay, got it.
So there's that. So that's kind of on the real-time side.
So the native MIDI API is like one of the big announcements.
I mean, for me, anyway, I mean, I think it's fantastic. And I would love to see loads more apps using MIDI and being controlled by MIDI devices.
Mm-hmm.
In fact, kind of a sneak preview. We're giving a talk I'm giving a talk at I/O, and we will be demoing this API and having like MIDI keyboards hooked up to phones and that kind of thing. Should be quite a fun sort of musical performance.
Oh.
So do you see this feature here, this native MIDI API? Do you see this as something like manufacturers like, I don't know who the companies would be, like, I guess Audio or whoever creates these keyboards, these audio manufacturers, are they going to be the ones that are going to probably create these like these integrations with their keyboards that they perhaps sell at various music stores, or what does this kind of open up the door to?
I mean, they can definitely create apps which can be used to configure their MIDI devices. Typically what we see is apps which are used for performance. So synthesizers and audio workstations, which just kind of natively integrate with whatever MIDI device is being plugged in. I mean, normally you have this process where you plug in a MIDI device and you tap on the screen in your audio workstation app, and you wiggle the fader or press the key on your MIDI keyboard, and you create a link between the two. So you can now, rather than having to use like on-screen controls, which can be a little bit fiddly, you can just use your MIDI controller for like much faster and easier control over the app. So I mean, potentially we see the MIDI device manufacturers creating apps, but it's more about the apps for musical creativity.
I'm just trying to wrap my head around, like, if I was a developer, maybe where I would want to, or how I'd want to use this, but I'm not really an audio developer, so I'm just having a hard time kind of gluing those pieces together in my head.
I guess if you're an audio developer, the main benefit is it's much easier for you now to integrate with any kind of MIDI device.
Okay, all right, sounds like a good selling point there.
Yeah, and like one of the things, and I can like speak from like some personal experience, one of the things that most folks always want to do is they want to maybe have like a keyboard or something at home, or like a musical instrument. And these days, a lot of these instruments are actually MIDI devices. So a lot of these keyboards that most folks purchase, like they're actually MIDI keyboards. And the advantage of having like these be MIDI keyboards is then you don't even need, for example, if you buy traditional synthesizer or keyboards, they actually have speakers right on them, right? So when you play something, like the sounds come right away. But with MIDI, what happens is all they do is they literally say, we process this into a signal that a computer can understand. So these instruments, all they do are they're just like instruments that produce this MIDI signal that can be understood by computers, right? Or like anything that understands the MIDI API. And so now what I can imagine happening is, instead of having to connect this to like maybe like a beefy workstation or like, my Mac here that has like complicated audio setup, maybe what one can do is like have like the setup and just connect it to like my Android device on the go. So I just have to carry my MIDI keyboard and like an Android device and, plug in my headphones to like the Android device, and then I can start playing all kinds of instruments, because then it's all pure software, right? So I can just keep switching on I can imagine like an Android app that just like switches between different instruments, and I can just use the same MIDI keyboard and then generate a whole range of sounds. Also because now I guess like the Android APIs support like that MIDI integration much better. It just enables like a whole bunch of possibilities around that. So I can see people like creating apps that just like do all kinds of funky things with sound, at least like this is immediately as Donn was mentioning this, those were the things that in my mind I was like constantly thinking about. I was like, oh, that would be pretty cool.
Actually a good use case would be your looping app. which we talked about right at the start. So you could have a MIDI controller, which is a bunch of just pads, really responsive pads. You plug that in, and every time you tap a pad, it starts a recording. You tap the same pad, it stops the recording. And they could be like really large pads, which may be foot operated, something like that. So you can be you basically recording loops as you're performing, as you're singing or playing guitar or whatever, and you could do it. Yeah, you could do everything through your phone, rather than having to tap on the screen.
Yeah.
So that's the real advantage of like MIDI controllers and using your phone. I guess it's like fully portable, and the fact that you have a controller there gives you a lot more control.
Right. The other thing I wanted to also ask you about is, I know like there's a lot of like new media codecs, and this I just read from the Android Q announcement, so I'm not necessarily even entirely sure of what the specifics are, but there's new codec support. There's like, I know media codec info has been improved. Can you talk to us about some of the exciting things there, like in Android Q?
Yeah, sure. So one of the things that developers were telling us was that it was difficult to find out the media rendering capabilities of a device. So like, can this particular device that my app is running on render H.264 at 25 frames per second in a frame size of 1080p? And they had to jump through various hoops, and sometimes it wasn't reliable. So there's been an addition to Media Codec Info, which allows you to know whether or not a codec is hardware accelerated, to know like where a codec came from, whether or not it's provided by the Android framework and is therefore available on all devices, or whether or not it's like a vendor specific codec, and a few other things as well. The other thing which was added is this concept of performance points. So a performance point is a way for a device to report its video rendering capability. So taking the example, taking the example that I mentioned earlier, you could say, okay, I've got this video, it's in H.264. What frame rates and frame sizes can you render, on this particular device? So you can then present that video in the best possible, quality and frame size for that particular device.
Oh, interesting. And so, got it. So like, different like applications that need to, and I imagine like, they like applications could just maybe pick the best one for this device because they understand, and then just like use that information directly, right?
Exactly. The other thing you can do, which is we see quite useful for apps which have a number of formats which they can choose from, you can say, okay, so I want to render a video at 1080p at 25 frames per second. What formats do you support at that particular sort of level of performance? So, and then you might get AV1 or H.264, and then you can choose the one which best fits your requirements. So it's all about providing bit more information to make it easy to render the best quality content at the lowest possible bit rate and things like that.
That makes sense.
So so in terms of others, in Android Q as well, we added support for AV1, which is an open source video codec. Yep. And that offers a much lower bit rate compared to, say, H.264 for the same quality. So,
oh wow! So I imagine for the same file sizes, you're presumably going to get better quality.
Exactly. Yeah. Exactly. So that's quite exciting. I mean, it's still early days for AV1 because there's quite a lot of extra cost in encoding. So there's no free lunch, but you shift the cost to encode, and there's a bit of extra cost in decoding as well. But if bitrate is your number one priority, then AV1 is a very good candidate for that.
and we're probably not going to go into the basics of bitrate right now because that's a different topic, but it's basically the amount of samples that you can compress in, the amount of audio rich information per sample that you can have. I'm not doing a great job explaining this, but just think of it as like the quality of the sound for folks who are curious.
Sure. Yeah. That's kind of a good way of explaining. The way I always think of it is how fast you need to transfer the data from a server to your phone in order to get a certain amount of quality. So it's kind of like how fat is the pipe? So if you're streaming at 4K, you need a really fat pipe. But if you're streaming at 1080p, you need a slightly smaller pipe. So it's it just in the case of AV1, it allows you to have a smaller pipe, but get the same quality as if you had a bigger pipe.
Oh, I actually like that explanation. I'm going to switch to that one.
So,
awesome.
Since we're talking about bit rates, another thing which is kind of a good thing in Android Q is we added support for the Opus encoder, which is an encoder which is optimized for speech. So it offers... And actually, I was listening to this today just so I kind of knew what I was talking about. It offers pretty incredible quality at very low bit rates. So if you have speech encoded at say 6 kilobits per second using MP3, it's barely legible. You will miss some words. Whereas with Opus, it's perfectly. You can hear everything being enunciated. It's perfectly understandable.
Oh wow! And I imagine some of the applications there are like, say, if you have, home speakers or like these devices where you need to send commands and these are being processed like somewhere else, like in the server. Like then being able to leverage this, the Opus format allows that, because then you can just like have much more clear information being sent in smaller packets. Is that like?
Yeah, exactly. Yeah, for sure. I guess as well for like video conferencing, things like that, it's much you can get much higher quality again for the same bit rate.
Makes perfect sense. Yeah.
You always forget about those apps sometimes. Like they just sometimes work, and you kind of forget that they're there, and that they have high demands in audio.
Yeah,
too.
Exactly. But I mean, before we started the podcast, we were talking about audio quality in video conferencing, and the amount of calls, certainly for me, the amount of calls that I'm on where the audio quality is just terrible or it drops out at a key point, it's quite astonishing. We assume that everyone has fantastic bandwidth all the time, but the reality is that, a lot of people, including myself, sometimes my bandwidth will drop down to like, less than a megasecond. And then you really start to notice it, and that's where these very low bit rate but high quality codecs come into play, that would maintain that kind of high fidelity and understandability when doing like video calls and things like that.
I think a lot of people, and this is an opinion that Kaushik shares with me, and you probably share as well, but we have the opinion that high quality audio is severely underrated. And the reason why we say this is like there's many times that both of us will listen to just various different podcasts or YouTube videos or whatever, and the content may be good, but the audio quality is so terrible that you just have to turn it off because you just can't even listen to it anymore because the audio quality is not
I couldn't agree more.
And
sometimes what I find is when I hear like good quality audio, like at the start of this call, I know you guys use great microphones, and it's a real joy to hear high quality, low noise audio. It's almost. I have a theory behind this, which is I think that there's a lot of cognitive load that goes into processing poor quality audio, because it's like trying to listen to someone in a busy pub, something like you're like, what? Oh, and you're having to process and kind of fill in the blanks the whole time. Whereas if yeah, if you have like high quality audio, it's so easy to listen to, so easy to understand. You can sort of relax into it, and not have to do all this extra processing.
I completely agree with that. And if you think about this in the sense of a video call, imagine when there's 10 people on a call, someone's unmuted, they're rustling papers. You can't focus on the person that's actually talking because you're so focused on someone rustling papers and you're getting irritated and like, what's the person just mute? And then before you know it, it's 20 seconds later and someone's like, hey, so can you, so-and-so, can you please mute? And then like you lost 30 seconds and that person's got to start all over again because no one heard what they were talking about. So I completely agree with that theory. Yep. It's a great one.
Sure. It's funny.
Yeah, I love it. Like, the cognitive load and like being like your brain almost being like a noise canceling system, where it's like trying to like cancel out and piece together the words and then make sentence. I love that theory. Yeah.
Well, hopefully some of these codecs can help solve some of those issues.
Definitely.
Awesome. What else? Is there anything else that you want to like talk to us about, like what's new in like media with Android Q?
I mean, just a couple of minor things. Android Q introduces support for directional and zoomable microphones. So it allows you to specify which microphone to use. For example, when you're taking a selfie video, you can say, give me the front-facing microphone. And also add support for zoomable microphones, which allow you to widen or narrow the depth of field for capture. So, for example, again, it comes back to what we were just talking about. Again, if you are speaking on a conference call, you may want a narrow depth of field so that the microphone will only pick up your voice rather than people rustling around in the background or whatever. So,
that's pretty cool. Yeah, even just phone calls, right? I imagine if you're taking a phone call, you want to like narrow the depth of field so that there's less outside noise. And
absolutely.
Stuff. Yeah.
And kind of segue into the camera, which is the camera. The depth information in the camera is now provided on Android Q. So. You can add in blurring effects, and essentially you can use the depth information to do whatever you like with. So whether that's blurring or like bokeh effects or creating 3D models, you'll be able to do that in Android Q as well.
Yeah, and I know this is like a whole different topic altogether, but like with the depth information photos, is it basically that like just more information is being stored, there are different pictures at different depth levels, and so then you can tweak the depth and then it just surfaces that versus like keeping it at a different level, or does it work a little more different? I imagine it's a little more complicated.
I think it's just metadata. So it's metadata which is in XMP format, which is embedded in a JPEG. I think it contains.
Oh, interesting.
I'm just reading what it says on the blog post here, but it says it has a depth and confidence map embedded in the same file. So it'll give you a whole map and how confident it is about whether or not the depth is what it says it is.
Got it. That makes sense. I mean, I can see why that is like valuable information.
Yeah. At the very least, it should produce some nice photos.
That is true. Donn, thank you so much for joining us. This has been like a complete treat for us, especially for me, I know, because this is like one of those topics in most folks, I don't know if you remember this, but in the early days of Fragmented, right? In like the first 5 or 6 episodes, Donn and I had this discussion about like this app that I've always been wanting to build. And then it's just been something that's like over time we've revisited now and then, but it looks like now is definitely Android is definitely there and more, where like it is at a point where you can do a lot of this stuff. The improvements, especially with the audio, is like, I'm very blown away by this. So this is both very encouraging and exciting. Cool.
I mean, thank you very much for having me on the show, and I'm very much looking forward to seeing this looping app on the Play Store. I'm happy to be a beta tester.
Perfect. I will definitely ping you. I got very excited and jumped into the show right away, but would you like take a minute or two to like also like tell us like what team you work at Google? Because like I also want to like recognize, like I know like the team has been doing like some amazing things, and I just like jumped in and started peppering you with questions. So we usually do this at the beginning, but like hey, better late than never. Like yeah, can you tell like some of the listeners?
Sure.
Yeah, where you work, what do you do?
So I work in the Android developer relations team. We are based in London, or rather, my direct team is based in London, and I'm the only person who focuses on audio. So I work with the Android audio framework engineers, essentially to help them bring their developer-facing products to market, and also to help developers use those products and give feedback to the engineering team in order to improve those products. So, for many years, developers have been saying, hey, what about latency? Can we make sure that that's not awful anymore? And, and so that message kind of propagates through me into the engineering teams, and they do a fantastic job of addressing that feedback. So, my job is really to provide the bridge between the audio framework team and audio programmers on Android.
Perfect. Thank you so much for joining us today, Donn. If folks have like questions, or they want to reach out to you with other like latency questions, I know in the early days I definitely probably reached out, maybe like even to you with some of these things. What would be a good way for like our listeners to get in touch with you if they have more questions around audio, or like they're curious about some of these capabilities?
Okay, so there's a few ways you can get in touch with me. Number one, probably Twitter. You can ping me directly, just at Donn Turner on Twitter. Also on the Oboe GitHub site, if you've got a specific question, or you want to know how to use Oboe in a certain way, then feel free to file an issue on the GitHub site there. We also have an Oboe Stack Overflow tag, so you can post questions there, and I generally check like once a day to see if there's any new questions there. So any of those ways, and I will do my best to respond. Sometimes I'm deluged with questions, so I'm not always the quickest to respond, but I do try and get to everyone eventually.
Well, thank you so much for your time, Donn. Thank you all so much for listening. We will catch you in the next episode.
Cool. Thank you very much.
I want to thank Sentry for sponsoring today's show. Their tagline is, "Your code is broken, let's fix it together." They're a super cool crash reporting service that gives you all the helpful details that you need when detecting and fixing errors in your application. Don't wait for your users to report your errors and crashes. Use Sentry to catch them earlier. Check them out at sentry.io/for/Android. Once again, because Sentry is a common word, I want to make sure you get it right. Sentry.io. My thanks to Sentry for sponsoring today's show. That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.